My name is Brian Ashley, and I'm a Principal Solutions Architect with Aviatrix. In this video, we will be discussing how the service principal Aviatrix uses to onboard accounts in Azure can be restricted down from our default contributor level access to a defined set of resource groups in which Aviatrix components are deployed. Aviatrix is a network and security platform with the goal of abstracting cloud complexity and providing a consistent deployment with advanced services across all the major providers. As a platform, the Aviatrix solution automates and orchestrates multiple components within the cloud environments to help make building networks in the cloud simple for customers. In Azure specifically, this orchestration is done programmatically through the use of a service principal, which allows the Aviatrix controller to make changes within specific subnets. Because of the large number of components that the controller is orchestrating, the simplest deployment for customers is to provide the Aviatrix service principal with contributor level access within the subscriptions. This assigns the appropriate access rights to allow Aviatrix to perform all the tasks and workflows within the platform. For some customers, though, this level of access may be too broad. Access may not want to be granted to the entire subscription, but limited to specific resource groups for which Aviatrix has control and authority to orchestrate. While this approach does allow for more granular control, it comes with a cost. There are some manual configuration steps which must take place. However, these can be integrated programmatically through Terraform as an example to increase the speed of deployments. What we'll do in this video is walk through my lab environment in which I have built a standard hub and spoke topology in Azure using Aviatrix while restricting the access Aviatrix has to specific resource groups. We will also look at some test VMs that I have deployed to verify that the service principal associated with Aviatrix has no ability to add, remove, or modify resources outside of its purview. So let's take a look at the details of the lab first. In my setup, I'm using a single Azure Active Directory tenant with 2 subscriptions. We're going to define one subscription for the IT department, who will be responsible for all of the networking and security within the cloud environment. The second subscription will be our workload subscription, in which we'll deploy our application compute, and this subscription may be managed by a specific business group or application team. Within each of these subscriptions, we have defined 2 resource groups. The service principal that we create for Aviatrix will have full permissions within these resource groups to orchestrate specific elements. However, anything deployed outside of these resource groups, Aviatrix will not be able to see. Once we create our service principal, we will build custom IAM rules which define the actions the service principal can take within these associated resources. Before we move forward, let's take a look at the custom roles we will be creating for this service principal. On the Aviatrix doc site, we have an article describing the use of custom roles for Aviatrix. For my lab, we will be using the custom roles at the resource group level. However, we will also have to create a custom role at the subscription level, but with limited privileges. The JSON displayed in section 4.1 here is the details for this subscription level custom role. Since part of the Aviatrix workflow require accepting marketplace agreements, we must allow this permission, which can only be done at the subscription level. As you can see, this is the only permission we are allowing for this custom role. If we scroll down to section 4.2, we will see the JSON which details the custom role we will be applying at the resource group level. As you can see, the permissions defined here are much more open. And looking at these permissions, you can start to see all of the activities that Aviatrix can perform within the environment. Again, the goal of Aviatrix is to abstract away all the complexity of building cloud networks. And in order to do that, the Aviatrix platform needs access to perform various actions. What is important to note here is that we will be assigning this custom role to the same service principal. However, we will associate this role with a specific resource group. The custom role at the subscription level will be inherited, so the service principal will have multiple custom roles for granular control at each resource group. Okay, now that we have seen what the custom role definitions look like, we are going to assign these roles to the service principal so we can begin to leverage the Aviatrix platform to build our environments. Again, we will assign the subscription level custom role to the service principal first, which will allow for accepting agreements. And then within each resource group we created for Aviatrix, we will assign the custom role created for that specific resource group. The service principal will inherit the appropriate permissions at each level, ensuring we have granular control. At this point, we can launch our Aviatrix controller and begin onboarding our accounts. We will onboard both subscriptions into the controller using the same service principal to do so. Once we have onboarded our accounts, we can begin building out our environment. As I mentioned previously, restricting the service principal does come at the cost of some manual configuration. What we will need to do first is build out our VNets and some route tables within the resource groups we created for Aviatrix, so we have the necessary pieces for Aviatrix to use. These tasks can be completed manually via the portal or through Terraform. In subscription 1, we will build out our hub VNet with a subnet for our gateways. In the lab, I also built a subnet for firewall egress and firewall management to deploy the Aviatrix FireNet feature, which orchestrates the deployment of next-gen firewalls. Within subscription 2, we will build out Spoke VNet with a subnet for our gateways and an application subnet. In Spoke 2, we will also want to build a route table which Aviatrix can orchestrate for our workloads. This route table will be associated to the application subnet that we created. At this point, all of the manual configuration steps are complete, and we can leverage the Aviatrix platform to build out the rest of our topology. Within the Aviatrix workflows, we deploy a transit gateway within subscription 1 with FireNet enabled. In subscription 2, we deploy a spoke gateway and then attach that spoke gateway to the hub. Lastly, we will deploy FireNet to service chain our next-gen firewall in the topology. After these tasks have been completed, we will have a hub and spoke topology leveraging Aviatrix transit and spoke gateways, with Aviatrix orchestrating the UDRs for our application subnet, and a next-gen firewall in our hub to provide filtering where required. Let's take a look at the topology at this point. Our topology consists of a hub and spoke architecture, with the hub, transit gateway, and firewalls deployed within the Aviatrix resource group within subscription 1. Our spoke consists of a spoke gateway with an application gateway and a route table, all deployed within the Aviatrix resource group for subscription 2. Aviatrix has visibility and control within each of these resource groups to automate the necessary UDRs within the application subnet and service chain the next-gen firewall as desired. Now, let's extend our topology and see how the access restrictions we put in place are carried out during further deployments. To expand our topology, we are going to deploy a test VM within our application subnet in Spoke 1. However, we are going to deploy this VM to a new resource group. In addition, we are going to create 2 new spokes, which will be deployed in new resource groups, with one spoke belonging to subscription 1 and the other belonging to subscription 2. We will deploy test VMs within each of those new spokes as well, so that we can verify what level of visibility and control Aviatrix has into these resources. To ensure we mimic a real-world scenario, we are going to create these new VMs and spokes using our CI/CD pipeline, which is outside of the Aviatrix provider and unknown to the IT group. We will assume that another deployment team needed to deploy some resources, and IT was not in the loop on this deployment. Once our deployment is complete, our topology now expands to a hub and spoke architecture with 3 spokes, each containing a test VM. Our initial spoke is the only one connected to our Aviatrix transit, and only the hub and spoke 1 are visible to Aviatrix. Notice that even though the VM in spoke 1 was deployed to a different resource group, the route table this VM is using is still being orchestrated by Aviatrix, as the route table was deployed to our Aviatrix resource group. This will allow Aviatrix to control routing without having access to the VM itself. Our new spokes have been deployed outside of Aviatrix resource groups, so our platform should have no visibility into those at all. Let's look at the Aviatrix controller to verify our access is limited to the Aviatrix resource groups only. If we look at our controller workflows, we have the ability to launch gateways within existing VNets. While logged in as an admin user within the controller, we have the ability to launch spokes in both subscriptions. Even though our admin user has that ability, you can see that if we are trying to launch a gateway in subscription 1, the only resource group available to us is the sub1 Aviatrix resource group. The same restriction holds if we try and launch gateways in subscription 2. Even though each subscription is using the same service principal, we have locked each account to its own resource group, so we do not have the ability to cross over. We can further restrict this access within the Aviatrix platform by leveraging RBAC groups on the controller. Within our controller, we can create two users, one for each subscription, and limit their actions and/or visibility to a specific subscription. If we were to log in as one of those users and try to deploy a resource into another subscription, the Aviatrix platform can also prohibit this behavior without having to depend upon the underlying service principal to do so. Lastly, let's take Aviatrix out of the mix completely and test the service principal through Azure CLI. This test would mimic someone gaining access to our Aviatrix service principal and trying to use it outside of our platform. If we log into Azure using the service principal, we are able to see both our subscriptions listed. However, if we were to list resource groups, we can see that we still only have access to the groups we have associated in our custom roles. Even though we have created other resources using the same subscription and credentials, the service principal we defined is locking our access to only those resource groups we have allowed. Thanks for watching this short video on restricting Aviatrix service principals in Azure. For more on how to restrict your service principals access, please reach out to your local solutions architect or email us at info@aviatrix.com.